Batch processing. At this time, the height of batch processing, there were no PCs. There were many dumb terminals and one giant CPU, but no PCs. Processing was centralized. Terminals did no processing, just typing. The alternative was to key punch. You keyed in your data on a key punch machine, and it put holes into this Hollerith card. That was your program. And then at the end of the day, your program would get stored. Finally, it would go someplace like here. This was data storage. Cartons of punched cards stored in a United States National Archives Records Service facility in 1959. Each carton could hold 2,000 cards. This was data storage back then. Wow. And then there was the IBM Portapunch. This was the first laptop. Designed to fit in the pocket, Portapunch made it possible to create punched card documents anywhere. So you're on a plane from New York to Los Angeles. A great idea hits you. You whip out that old IBM Portapunch from your pocket and start punching holes into the Hollerith card. Wow. It was intended for on-the-spot recording operations. Thank you, Wikipedia, for that wonderful picture. There was also something called job controlling. It allowed you to prioritize jobs that were waiting in the queue for execution. Time sharing also evolved for online users. Wall Street and the oil industry came up with a buzzword at that time called real time. In Wall Street, everything had to now be done in real time. And mini computers emerged to meet the real-time processing needs of corporate America. But real-time is relative, and it is application determined. What is real-time? The application determines that. So we have strata of software interfacing with hardware on our computers. Let's talk about that hardware. On the hardware side, we have I/O devices that interact with CPU and memory. How is that done? Well, it's done with a device called the bus. A bus would allow for communication to critical computer components. What components would that be? There's these three main players here: CPU, memory, and I/O. They come with each other over the bus. While this component, the I/O, interfaces with the outside world also. But I/O devices operate at their own slower speed. Older devices operate at super slow speeds, requiring a separate bus, slower than the other bus. While more modern devices can communicate over a much faster bus. So what is a bus? Well, it's a set of lines through which pass electronic signals. And the CPU used to be the master of the bus and control signal flow across these lines. But CPU time is wasted while waiting for I/O device response. Now another device is normally in charge of bus communication. It's called a channel controller, and it orchestrates signal flow across these bus lines. It is far less complex than the CPU, but capable enough of mastering the bus. Although occasional CPU intervention will be requisite. Memory is the slave device, period. CPU demands memory from memory, and memory obeys. Memory hands over all the memory the CPU wants. The I/O communicates with internal and external devices. Keyboard, printer, and monitor types will require a unique interface, though. Where? In the I/O box. DOS Matrix, Laser, Inkjet, all these are different printers and they get different interfaces. But communication twixt the CPU and I/O must be standardized. So device capriciousness must be absorbed in the I/O box. The I/O box must hide the devices from the other side of the interface. For example, monitors may utilize a raster, random, interlaced, or progressive scan. But scan type must be hidden from the other side of the interface. And that's it for now. Logically yours, George Bull. Logically yours, George Bull.